Okay, ladies and gentlemen, what we have here, we're going to finish up with section 2.3. This chart has some solutions of a linear function, and we're asked to find the equation of that linear function. The first ordered pair that's going to catch my eye is the ordered pair 0, 9. And the reason that that ordered pair is so important, 0, 9 means that b is 9. Remember, whenever you see x is 0, the number that follows is the y-intercept. b equals 9. So we already know b for our formula y equals mx plus b. Now, to find the slope of a line, which is missing here, you need two ordered pairs. Well, I already have the 0, 9 is one point I'm using. I'm going to go to my chart and pick another point. And it doesn't matter which one I pick, I'll choose the ordered pair 2, 13. I can use any. I then go to my formula. Slope is change in y over the change in x. So up top I have 13 minus 9. On the bottom I have 2 minus 0. 4 divided by 2 becomes 2. So the slope is 2. Slope is 2. B is 9. Therefore my equation of the line is y equals 2x plus 9. And remember, this change in y over change in x is the very same. If you've learned y sub 2 minus y sub 1, that is called the change in y. X sub 2 minus x sub 1 is called the change in x. Okay, let's look at some applications here. This function measures the winning times for the 200-meter dash. You're first asked for the slope of the line. The slope of the line is the number in front of the x, which is a negative 0.05761. Now the most important thing to know when it says interpret the slope, this means that every year the winning time goes down. It decreases by that number of seconds, which really means that every year your competition is getting stiffer. You have better runners. Okay? Now, part C. What is this expected to do over a 4-year period? Now, there's one of two ways you can answer this question. If I just want to know what's going to happen over the 4-year period, all I would do is I would take negative 0.05761 and multiply it by 4. Okay? Just that part. And I could tell somebody that over 4 years, that's how much the winning time is going to decrease by. Then, if I want to know what the actual winning time is at the end of the 4-year period, I add back in the 149.7, which gives me 149.47. So basically the 149.47 is going to be the actual winning time at the end of the 4-year period. But on Course Compass sometimes, and you need to pay attention to your question, it just asks you what's going to happen, what are the winning times going to do over the 4-year period. They only want you to take the negative 0.05761 and multiply it by 4 and let them know that it's going to decrease by that number. So basically, like I tell my students, always answer the question. And our final question. If a swimming pool is leaking, okay, X represents the days since the leak started and Y represents the number of gallons in the pool. I only need, on my graph paper, I only need to be in quadrant 1. That's why I've only drawn the first quadrant. Because in quadrant 1, the time is positive, okay? As I move from left to right, I have positive numbers. Hopefully you understand why the slope of this leak is being measured by a negatively sloped line, and that's because you're losing water. So it's a negative slope because the water level is dropping. What would the y-intercept represent? Let me put my cursor on it. The y-intercept represents how much water you had in the pool to start with. That would have been the full pool with no leaks. Now let me make one other comment. If the pool wasn't leaking, watch what I'm doing with my cursor. If the pool wasn't leaking, the water level would have remained constant. Yes? And you would have had a constant function. Okay, it should not be leaking. It would have remained constant. However, because of the leak, negative slope and the y-intercept represents the original number of gallons of water in the pool. Okay, we're done with 2.3.